Have you ever really thought about where your power comes from? I mean, for most of us, it's just this thing that comes out of the wall, right? But it's actually coming from some massive, distant plant connected by thousands of miles of wire. Well, what if that whole idea is about to change, fundamentally? Today, we're going to dive into a really powerful new vision for energy. A shift from the massive to the micro, from the city grid right down to your very own home. Let's explore what that future could look like.
So, first things first, why do we even need to change? The simple answer is that our current power grid, this incredible marvel of 20th century engineering, well, it's really starting to show its age. It's centralized, it's unbelievably complex, and it's becoming more and more vulnerable to, well, everything from extreme weather to modern cyber threats. And that's really the heart of the problem. Our world today, think data centers, electric cars, all of our smart devices, it demands constant, clean, totally reliable power. But we're plugging all of that into an infrastructure that was designed for a completely different time. It just wasn't built for the kind of resilience we desperately need today.
Okay, so how do you solve such a massive problem? Well, one of the most fascinating answers that's starting to emerge is a complete rethink of nuclear power. But hold on, this isn't your grandfather's nuclear plant. This is what's being called the micro-nuclear revolution.
A micro-nuclear power plant, or MNPP, is pretty much what it sounds like. It kicks out about 1 to 50 megawatts, which is enough to power a small town or a big factory from a tiny, sealed, and super automated reactor. You should think of it less like a sprawling industrial complex and more like a self-contained power battery that's designed to be built in a factory and shipped wherever it's needed.
Now, to really get how different this is, you have to remember the old way of doing things. These huge, large-scale nuclear plants are just monumental projects. They can take more than a decade to build and cost billions and billions of dollars, locking us right back into that same old, centralized model.
And when you put them side by side, the difference is just staggering. I mean, look at this. Construction time over 10 years versus maybe 1 to 3 years. Billions in cost versus millions. And maybe the most important thing, the impact of a failure goes from a potential national crisis to something that's purely localized. It's a total, complete change in philosophy.
But of course, I know what you're thinking. Anytime you mention the word nuclear, the first question is always about safety. And this is where these MNPPs really represent a massive leap forward. It's all about building trust right into the laws of physics itself.
The key concept here is something called passive safety. All this means is that the reactor is designed to fail safe. If something goes wrong, you don't need operators frantically flipping switches or backup generators to kick in. It's kind of like a self-regulating kettle. If it starts to overheat, the laws of physics, things like gravity and natural air circulation, cool it down automatically. Nobody needs to run over and flip a switch.
This slide directly tackles the fears from past nuclear accidents head-on. That big risk of a core meltdown, the new designs make it physically impossible. A hydrogen explosion like we saw at Fukushima, the coolants they use literally don't create hydrogen. The entire design is a direct answer, engineered to eliminate those historical failure modes.
I just want to pause on this for a second. Physically impossible. This isn't just a goal or a marketing slogan, it's a design principle. The materials and the physics used in a lot of these advanced reactors mean that they simply cannot melt down in the way older reactors could. That is an absolute game changer for public trust.
And what about the cost? Well, because these things are built in a factory, the economics become way more predictable. You see here, the bulk of the cost is in the reactor module itself, and that allows for economies of scale, driving the price down as more and more are produced.
So this leads to a projected cost of electricity that isn't just competitive, it's incredibly stable. Unlike natural gas or coal, the price isn't tied to these crazy volatile fuel markets. You get clean, reliable power at a predictable cost for decades.
So that's the macro solution. That's the big picture. But here is where the story gets really interesting. What happens when you take this exact same philosophy, sealed systems, passive safety, distributed power, and you apply it not to a city, but to a single home?
And when you actually compare the philosophies, it's amazing. They're basically identical. A sealed nuclear core becomes a sealed fuel cell stack. Passive safety that's based on physics becomes safety that's based on self-limiting chemical reactions. It's the same genius idea, just using a different kind of technology.
And that brings us to the home fuel cell micro power plant. Think of it as your own personal, silent, clean power station designed to give you complete and total energy independence.
So how does it work? It's actually beautifully simple. A fuel, like natural gas or maybe hydrogen in the future, gets fed in.
The fuel cell stack then converts it directly into electricity using a chemical reaction. There's no combustion, no noise. That electricity powers your home, any extra heat gets captured for your hot water, and a little smart brain just manages everything automatically.
The benefits for a home are just incredible. It's ultra quiet. We're talking quieter than your refrigerator. If you capture the heat, it can be up to 90% efficient. And crucially, it works day or night, rain or shine, giving you a constant, reliable source of power no matter what. And just like its micronuclear cousin, it's designed to be inherently safe. There are no flames, no explosions. The safety message is wonderfully simple. If it fails, it just stops. That's it. Nothing dramatic happens.
So how does this actually stack up against your other options? Well, solar is great, but it's not always on. And it totally depends on the weather. A diesel generator is always on, sure. But it's noisy, it's polluting, it's anything but premium. The fuel cell is really the only solution that ticks all the boxes. Always on, silent, and completely weather independent.
So, when you put these two ideas together, the micronuclear plant for the city and the fuel cell for the home, you start to get a glimpse of a completely new energy future. A future that isn't centralized, but is instead distributed.
And the implications here are just huge. This isn't just about keeping the lights on. This is about energy sovereignty, for nations and for individuals. It's about building a grid that's actually resilient to climate change. And it's about providing the stable, clean power our industries need to compete and to thrive.
Ultimately, what we're talking about is moving from a world where we're just passive consumers of energy to one where our homes and our communities are active participants. So the final question isn't just about what new power plants we're going to build, but what role will each of us play in this new distributed energy future?